Hello friends. After the electric potential due to the dipole, next article is the equipotential surface. This is a very important concept, equipotential. First see the meaning of word equipotential. Potential, this is related to the electric potential. And electric potential means what? Electric potential is electric potential energy per unit charge means the electric potential, and equi means equal or the same. Okay, suppose any conductor is charged with a specific charge, then first of all it is clear that the charge is uniformly distributed over the surface of the conductor. For example, let this is a one sphere, that O is the center of the sphere, and just we are showing the 1, 2, 3, 4, 5, 6 points on the surface of the sphere, and this sphere is charged with a charge of 6 microcoulomb. Then this charge is uniformly distributed over the surface of the sphere. Therefore, at every point, let A be the point B, C, D, E, and F. These are the points on the sphere, and at every point, this 6 microcoulomb charge is distributed. Means what happens? At the point A, 1 microcoulomb charge. At the point B, 1 microcoulomb charge. C also 1 microcoulomb charge. At the point D, charge of 1 microcoulomb. At the E, 1 microcoulomb. At the F, 1 microcoulomb. Means there is a charge at every point. That is a point at A, B, C, D, E, F. At every point, there is a same distribution of charge. Charge is equally distributed. Charge is uniformly distributed. Okay. Means there is a first thing is clear that distribution of charge is uniform. It is always there is a uniform distribution of charge takes place. Okay. Now one more thing. Now A is situated at a distance r from center, B is situated at a distance r from the center, C is situated at a distance r, D is situated at a distance r, E, F. All the points are situated at a distance r from the center. Now first of all we calculate the electric potential at the point A is given by 1 upon 4 pi epsilon 0 Q divided by R. Okay. Now for the point A, let the charge at the point A, and distance of point A, it will be R. Okay, just I am writing in this way. For potential at the point B, it is also same 1 upon 4 pi epsilon 0 QB by R in the same. Therefore, the potential at the point A, potential at the point B, at the C, at the D, at the E, at the F, it will be remains same. If the potential is remains same, then work done equals to what? Work done is VA minus VB or VC minus VB. Work done means what? We have to displace the charge from B to A. Means at that time potential at the point A minus potential at the point B. That is my work done. But VA minus VB, there is a difference in the potentials. But the potentials are same, then difference is also 0. Means when the charges are uniformly distributed and charges are separated by a same distance or at a fixed distance, then their electric potential energy is always the 0. Therefore, remember one thing, distribution of charge is same or distribution of charge is uniform, then distance of charge is same, then electric potential energy equals to 0. Here we have to take the electric potential energy 0. Why? Because the work done equals to 0. Work and potential energy are the same. Therefore, if the work done is 0, then obviously electric potential energy is 0. Means if there is a first point which is very relevant or very important, when a charges are uniformly distributed over the surface of the sphere, and uniform distribution of charge is there, and every point is situated at the same distance from the center, then the work done is zero, or electric potential energy is zero. This is the most important sentence from this article. Now just we have to write down shortly, very shortly, for the first point. For sphere, condition is what? Uniform distribution of charge and instead of separation we also say that the potential is same, then work done or electric potential energy is zero. This is the most important point. Just everyone write down this is your this point in your notebook. Now the work done is, what is the basic formula for work done? The basic formula for work done is work equals to force multiplied by the displacement. Okay, so I am writing the force is F and displacement is a dx. Now work done is a which type of quantity? Then it will be very simple. Work done is a scalar type of quantity. So my work done becomes F dot dx here, F dx into cos of theta. Now just we see this is a one formula for work done. See one more formula for work done is work done equals to, just here F is there, that is a force. Instead of force I am writing 1 upon 4 pi epsilon 0 q into q divided by r square into separation between them is a r, or displacement is a r, 1 r get cancelled, so it becomes 1 upon 4 pi epsilon 0 q divided by r into q. This is nothing but my electric potential, so I am writing work done is given by V into Q. This is one more formula, just write its explanation also. Now the electric intensity is given by one formula, electric intensity. Okay, that will be seen afterwards. The work done is given by potential multiplied by charge. Work done is given by F dx cos of theta. Suppose the surface is an irregular surface. Okay. Now the surface it will be looks like this. This is my one surface. Okay. The charge is situated here at this point. Q is the amount of charge. From this charge, the electric lines of forces are emitted. This is my direction of electric intensity. Now, okay, from this point and at this point P, we are measuring the electric intensity. This is in this way. Now we have to displace a 1 unit positive charge from P to this upward side through a short displacement dx. Okay, dx is upward, displacement of the charge is in upward direction and the electric intensity is horizontal direction. Now check the angle between intensity and displacement. What is the angle between intensity and displacement? Here the displacement is in upward direction, intensity is in x direction or along x direction. Then angle between them, here the theta is equals to 90 degree. Then its work done becomes F into dx into cos of theta. So it becomes F into dx into cos of 90 degree. Cos 90 is 0. So entire work done becomes 0. This is one more thing. So when a surface, when a displacement is exactly perpendicular to the direction of electric intensity, then work done is equals to 0. So from this formula, we have to write one more point in your notebook. When displacement of charge and electric intensity are perpendicular to each other, Just I am writing here theta equals to 90 degree, comma cos of 90 degree equals to 0. At that time, work done or electric potential energy is 0. At this point also in your notebook. Okay. Now we see the one more formula. Just we are checking this. Work done is given by 1 upon force multiplied by displacement. I am writing in this way. Force multiplied by displacement. Let displacement between the two charges is R. The work done is 1 upon 4 pi epsilon 0 q divided by R square. Here 1 R get cancelled and the work done becomes 1 upon 4 pi epsilon 0 q by R into q. This is nothing but my electric potential. So my work done becomes here work done equals to V multiplied by q. Add this one formula, work done equals to potential multiplied by q, or simply potential is nothing but work done per unit charge or electrostatic potential energy per unit charge. Now just we see how you calculate the electrostatic potential energy when there are the two charges are present. Okay, just we see that one. First of all, write down all the 3 important points in your notebook. Then we see the next part. Electrostatic potential energy. This is our simple Cartesian coordinate system. O be the origin. This is my x-axis, z-axis, and the y-axis. Okay. Here the one charge is situated at a point. Let Q1 be this charge is situated at a point A, and the point A is situated at a distance R1. One more charge Q2 is situated at a point B. Now that point B is situated at a distance R2 from the origin. Now the electric potential at the point A is given by electric potential at the point A is given by 1 upon 4 pi epsilon 0 q divided by R1. Here remember that potential is a function of distance because charge is the same. There is a Q1 with the same charge. But as I vary the distance, then what happens? Electric potential changes. Now potential at the point B is how much? Then it will be very simple. 1 upon 4 pi epsilon 0 Q2 divided by R2. And the two charges Q1 and Q2 are separated by a distance R12. Means Q2 is situated at a distance R12 from the Q1 charge. Okay? Or point B is situated at a distance R12 from A. Now we have to calculate the work done. Then how you find out the work done? The basic formula for work done is what? Potential multiplied by charge. Here I am displacing the charge Q2 towards the Q1. Okay, remember displacing the charge Q2 towards the Q1 means I am shifting the charge Q2 from point B to the point A. Means the displacement is how much? R12 is my displacement. Okay, so I am writing here electric potential multiplied by this charge. So find out this electric potential is a 1 upon 4 pi epsilon 0 Q1 multiplied by charge is how much? Because I am displacing the second charge Q2 towards the Q1. So that at that time my work done becomes 1 upon 4 pi epsilon 0 Q1 Q2 divided by R12. Just I am simply writing this way 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. When the two charges are there and we are displacing second charge from this, then formula becomes 1 upon 4 pi epsilon 0 Q1 Q2 by R12. Now think exactly vice versa. Suppose I want to displace Q1 towards the Q2. Then what happens? Q1 is the Q, then my formula becomes electric potential, because we are displacing charge Q1 towards Q2. So first I am writing the electric potential of second charge, that is a Q2. So formula becomes 1 upon 4 by epsilon 0 Q2. We are displacement of which charge takes place? First charge, that is a Q1 divided by R21, means we are measuring the distance from second point, okay, from Q2. So distance becomes R21. No matter R12 and R21 are the same, but obviously the potential energy remains the same. Just symbolically there is a difference. But suppose the point is present here, then there will be sign changes. Okay. So the work done or electric potential energy, symbol of electric potential energy is a U, or just I am writing here electric potential energy U equals to 1 upon 4 pi epsilon 0 Q1 Q2 divided by R12. Okay, mention also this. When there are the two charges are present, then electric potential energy is given by in this way. Now the second part, when there is a system of n number of charges, when capital N number of charges, or just you have to mention here when 4 number of charges are present, then what is the how you express the electric potential energy? 4 charges are present, so obviously I am selecting a one simple square. Okay, each side is a 1 meter, 1 meter, 1 meter, and 1 meter. Okay, here the charge is Q1, Q2, Q3, Q4. Or just we say there are the R is a distance. Okay. And now we have to find out, and these points are A, B, this point is a B, this point is a, this point is a C, and this point is a D. To avoid your confusion, just I am symbolically expressed by different colors. These are my points. A, B, C, D are my points, and these distances are, or every charge Q2, Q3 separated by R, or each side of the square is of distance R. So Q1, Q2, Q3 and Q4 are the charges. Okay, each side of square equals to R. Now we are calculating the total potential energy. Okay, so at the point A, so I am writing here total electric potential energy at the point A, means first of all we calculate what are the charges which produces electric potential at the point A. Then it will be clear that Q2 produces electric potential on charge Q1, Q3 produces some electric potential at the charge Q1, Q4 produces some electric potential at the charge Q1. So just I am writing it is the U, that is the electric potential of first charge and the second charge. How you calculate this electric potential equals to, first of all, the distance 1 upon 4 by epsilon 0 into product of two charges, that is a Q1, Q2, divided by distance between the two charges. Between Q1 and Q2, the distance is R. It will be very simple. Now the distance between Q1 and Q4, that is the A and B, that we also calculate 1 upon 4 by epsilon 0 Q1, Q4 divided by this distance is how much? Is R. Then this Q3 also, it becomes a 1 upon 4 by epsilon 0 Q1, Q3. What is this distance? Now question is, what is this distance? AC or CA? Because we are displacing this charge here. So what is the distance CA? Observe the diagram very carefully. It forms a one Pythagoras. Yes, it forms a one Pythagoras. Then here it becomes what? AC square equals to height square, that is a AD square, then a D ADC square. What is the AD square? It's a R square plus R square. So it becomes a 2R square. The AC square means 2R square. So is equals to how much? Root 2 times of R. So I am mentioning the root 2 times of R. Then the total potential energy at the point A. Total potential energy at the point A equals to, it is nothing but the sum. So I am taking 1 upon 4 pi epsilon 0. Observe this. This is a common part. So in bracket Q1 Q2 divided by R, Q1 Q4 divided by R plus Q1 Q3 divided by root 2 times of R. Okay, or one making this way, 1 upon 4 pi epsilon 0 Q1 divided by R in bracket Q2 by 1, Q4 by 1, Q3 divided by root of 2. And substituting the value, we can easily solve this. Suppose one thing is happened. This Q3 is a negative. Then no matter, only there is a, here comes the negative sign. Q4 is negative. Here comes the negative sign. And we can take the algebraic sum because it is a scalar type of quantity. Also, note down, if there are only the two charges, then in this way we can calculate the potential energy. If there are more than two charges, then the general formula becomes in this way: Q1 Q2 by R, Q1 Q4 Q4 by R. In our textbook, the distance is mentioned in this way. It is a 1 2. This is a 1 4. This is a 1 3. In this way it will be mentioned. But we are specifying the distances are R because we are selecting a one specific charge. Okay, and its distance is also a fixed distance. So that term becomes like this. Just I'm erasing this. It produces a confusion to you. Okay. Now one more thing. We can express same in terms of electric potential energies when the surfaces are equipotential. For example, in this way, this is a one sheet. In front of that, we have to place. In front of that, we have to place one more sheet. In this way, and the charges are uniformly distributed. Then the electric intensity is exactly perpendicular from this sheet. Suppose this is a one positive charge, electric intensity is passing. These are the directions of electric intensities. At every point, the electric intensity is same because the charges are uniformly distributed, surfaces are exactly parallel, and remember that the electric intensity is always perpendicular to the surface. If it is always perpendicular to the surface, this is my surface, then at every point electric intensity makes an angle of 90 degrees with the surface. And this electric intensity, very important thing is, this electric intensity at every point electric intensity. Suppose this is my point A, point B, point C, then electric intensity at point A, electric intensity at point B, electric intensity at the point C. At every point electric intensity is the same. One more thing, it is a parallel. And one more thing for objective type of questions. When a surfaces are exactly parallel, the charges on the surface are uniformly distributed. Remember that when the surfaces are, or uniformly distributed surfaces are parallel to each other, remember the surface is parallel to each other, then electric intensity is perpendicular to the surface. Electric intensity is perpendicular to the surface. This is my surface. Electric intensity is perpendicular to the surface, and if you are choosing a different points, electric intensity at every point is parallel with each other, not the surface. Okay, parallel with each other, perpendicular to the surface, parallel with each other, and most important is electric intensity never intersect because they are parallel, like the rails. Okay, like therefore such a electric intensity is never intersect. Important thing is what? Electric intensity never intersect. Suppose a dipole is present. Last article we studied the dipole. Dipole is a two charges are there. Then first possibility is what? The charges are like charges. Okay, the charges are like charges. So this is the one small sphere, this is the one more sphere, this sphere is a positive, this sphere is a negative. Then what is the positively charged sphere? The charges are distributed over the surface. From the surface, the electric lines of forces are emitted because positive charge emits the electric lines of forces. Then this positive charge emits the electric line of forces. This positive charge emits the electric line of forces. This positive charge emits the lines of forces. This positive charge emits the lines of forces. This positive charge emits the lines of forces. Now observe that I am telling you once again and again, electric intensity or electric lines of force is perpendicular to the surface. Means from this surface, suppose this is my small surface, just I am showing by different color, and the intensities or electric line of force is perpendicular to surface. Means it makes an angle of 90 degree with the surface here. Okay. If I am taking this small cross section, then it is perpendicular. So my directions of electric intensities are like this. And all electric intensities are ends at which charge? Because ends at the negative charge, because all the lines of forces are ends at this particular negative charge. So when there are the like charges are there, then diagrammatic presentation is like this. Okay? And such a type of questions are asked for the NEET and JEE also. When you open your Singhage book, then you observe, okay, the lines of forces or intensity ends at which charge? Ends at the negative charge. When the two charges are present, two charges are separated by a particular distance, means if there is an electric dipole. Now one more possibility of dipole is that both the charges are, this is what unlike charges. Both the charges are the like charges. Both the charges are like. Means suppose I am taking the positive and positive. One more possibility is that there is a negative and negative because both are the like charges. From positive, the lines of forces are emitted. From this positive, lines of forces are emitted. These lines of forces are emitted in this way. But that charges or this line of force never reach towards this side because this is my positive. So the lines of forces are repairs. Therefore, their directions are like this, not in this way. And here also. Okay, when there are the like charges, then electric lines of forces, electric intensities are opposite to each other. Now, negative charges are there. These are also like charges, but there is no any diagrammatic presentation because what happens? At the negative charge, there is from the negative charge, there is no emission of line of force. Therefore, here only the lines of forces are terms. Suppose from a particular distance or at some particular distance, positive charge is there, then the electric lines of forces are reached towards the negative charge. The diagram will be looks like this. Okay. See the shapes very carefully because that question it will be arises only on a diagram. Okay. Some diagrams are given and the charges are given and the question is like this: which one is a correct presentation of the electric intensity? Which one is a correct presentation of electric line of force in this? Now the next and last article before the new point or second part of the electrostatics, that is part of the capacitor. The last article is the electric dipole moment. Okay, electric dipole moment, but we are expressing electric dipole moment how it produces a torque. Okay, so the article is the expression for torque. When expression for torque, but the condition is what? When two charges placed in external electric field. Let that electric field is a uniform electric field. Okay, when the two charges are placed in a external uniform electric field, then torque is produced. How the torque is produced? What is the formula for electric dipole moment? And all we have to study in this field. Now the electric field is a uniform electric field. So I am drawing my parallel lines. This is my uniform electric field. Parallel line indicates the electric field is a uniform. The electric field is expressed, the strength of field expressed in terms of electric intensity for a vector type. Okay, so this is my direction of electric intensity. The spacing between all lines is the same, so we say that it is a parallel, so it is a uniform electric field or the uniform electric intensity. The two charges are there. These are my two charges. One is charge, one charge is present here and one charge is present here. Okay, this is my positive charge plus Q, this is my negative charge minus Q. These are my the two charges, and these two charges are separated by distance 2L. Are you getting this? Plus Q charge is at point A, minus Q charge, just I am writing here, minus Q charge is present at the point B. Now these two charges, first we consider one by one. Okay, plus Q charge is placed in a uniform electric field E. Okay, or the uniform electric field is acting on a plus Q charge. Therefore, at the point A, electric field produces some force at the point A, or electric field produces a force at point A on plus Q charge, because plus Q charge is present at the point A. Now what is that force? Now how you calculate the force? First of all, basic formula for force. No one say it's a mass into acceleration, because we are not studying here the mechanics. Okay, we are studying here the electrostatics. So electrostatic force is given by simple formula 1 by 4 pi epsilon 0 product of two charges square of distance multiplied by. This is formula for force here. And the electric intensity is given by, just I am expressing the charges are Q and Q. Electric intensity is given by 1 upon 4 pi epsilon 0 Q by R square. Observe both the formulae very carefully. Input intensity 1 upon 4 pi epsilon 0, both the terms are constant. R square at the denominator both are same. In force Q and in intensity only a Q. So can I say in this way? This is equals to 1 upon 4 pi epsilon 0 Q by R square into Q. What is this white chalk color term? This is nothing but my E intensity. So my formula becomes F equals to E into Q. Okay, just write down in a rough space. This is for your understanding only. Mention in the text and notebook also. Now here the force is acting, and the force is how much? Q into E. This is my magnitude of force, and the direction of force is what? This force is along the direction of electric intensity. Why it is along the direction of intensity? Why it is not against the direction of electric intensity? The answer is very simple. The charge is positive. Therefore, there is no any difference. So the force is in the direction of electric intensity. Cn. Minus Q is a charge. So the electrostatic force becomes Q into E. But this is negative. This is positive, because here the charge is negative. So the direction of force is against the direction of intensity. If the electric intensity, its direction is along positive direction of x-axis, then here the force is along the direction of negative axis, because intensity and charge are opposite. So the force is obviously against the direction of electric intensity. But force is a vector type of quantity. Just we see the magnitude. Okay, if I see the magnitude, force acting at the point A is how much in magnitude? It's a QE. Force acting at the point B, it's a what is magnitude wise? It's a Q into E. Then see very carefully, both the forces are equal in magnitude. QE, QE, their magnitudes are same. Therefore, force acting at point A, force acting at point B, both the forces are equal in magnitude. But remember that their directions are, yes, their directions are opposite to each other, because QA produces force along the positive direction of x-axis. QB, charge at the point B, produces at that point the force is in the negative direction of electric field, negative direction of electric intensity, opposite to the direction of electric intensity, and at the point A, in the direction of electric intensity. Okay. Therefore, the forces are equal in magnitude. So I am writing here, forces are, which forces? That FA and FB equal in magnitude and opposite in direction. If the two forces are equal in magnitude, opposite in direction, then they produce pure rotational motion. Okay? When two forces are equal in magnitude, opposite in direction, then they produce pure rotational motion. And to perform rotational motion, the responsible quantity is torque. Or in simply, torque produces rotational motion. So I am writing here, torque produces rotational motion. Okay. Now what is the basic formula for torque? Torque is given by either force multiplied by perpendicular distance. Now what is the force? Force is Q into E multiplied by perpendicular distance between the two forces. Now draw one perpendicular here, also draw one perpendicular here. This distance is a perpendicular distance. Like this point is a C point. Now observe the diagram very carefully. Here it makes an angle theta. This is also theta. This is also theta. No problem. Okay. Now AC is opposite to the theta. So I am using trigonometric function. Yes, it's a very good. It's a sine of theta. Then sine theta becomes how much? Sine theta equals to opposite side. That is a AC divided by this hypotenuse. It is a 2L. So what is my AC? AC is 2L into sine theta. So I am writing here perpendicular side is a AC. It becomes a 2E into 2L into sine of theta. Just I am rearranging the terms. The term becomes Q into 2L into E into sine of theta. But what is Q into 2L? Charge multiplied by distance between the two charges. Not a perpendicular distance. Charge multiplied by distance between the two charges. It is nothing but electric dipole moment, and symbolically expressed by P. So it becomes a PE sine theta. So symbol of torque, tau equals to PE sine of theta. Or in vector form, you can write tau, vector tau equals to P cross E. And when there is a vector product A cross B, AT sine theta, P cross E, PE sine theta. So tau equals to vector P cross vector E. This is the most important relation. Okay. And in our textbook directly we mention from this step. So I comes to this point. The torque is given by tau equals to P cross E or Now here displaces this. Suppose I am changing the position of this point A. As I changes the position of this point A, what happens? Then the theta changes. Okay. Therefore, there are some limits how this it will be changes. Therefore, I am writing the resultant torque is given by integrate, because we are changing the positions of theta. Suppose theta 0 is my initial angle and final angle is a theta. It will be possible theta 0 it may be 0 degree. 0 to we can change up to the 360. Some more change 0 to 90. So 0 to 90, 0 to 180, 0 to 270. This way we are mentioning the general formula theta 0 to theta. So this torque equals to this P and E are constant. Okay. Then into d theta. So integrate this integration of theta 0 to theta sin theta into d theta. Now the question arises, what is the integration of sin theta d theta? The answer it will be very simple. Derivative of sin theta is a cos theta, but integration of sin theta is a minus of cos theta. So it becomes a PE into minus of cos theta, theta 0 to theta. Now substitute the first value of upper limit. So it becomes a PE minus of cos theta minus of cos of theta 0. So term becomes PE in bracket minus cos theta plus cos of theta 0, or tau E equals to PE in bracket cos of theta 0 minus of cos of theta. So this is my total expression. Torque equals to PE in bracket cos of theta 0 to minus of cos theta. This is my required expression, general expression. Now we study the different cases. Now the first case. Initially theta 0 equals to 0. Then what is the value of torque? P in bracket cos of 0 degree minus of cos of theta. Then tau equals to P cos 0 is a 1, so it becomes 1 minus cos of theta. This is my first case. In a second case, initially theta equals to 90 degree or pi by 1. Then tau becomes PE cos of 90 degree minus cos of theta. Just substitute that value. Cos 90 is a 0, so it becomes a 0 into minus of cos theta. So tau becomes a minus of PE into cos of theta. This is my second expression. Initially theta equals to, or theta is at 90 degree, sorry 180 degree, then it becomes a minus of 1. Minus 1 into minus of cos theta, it becomes a minus of PE. In this way we have to express that. Okay. These are very simple cases, just we are substituting the angles, then we are getting the formula. Okay. Today we study the different points. Okay. One is meaning of equipotential, same potential, at that time work done becomes a 0 if the surfaces are identical. And remember that the potential, if the charges are uniformly distributed, then potential is depend only on the distance. But if there is a sphere is there or solid circle is there, then what happens? The distance of every point is same, because the radius of that object is the same. Therefore, the work done or potential energy equals to the 0. If the displacement and electric intensity are opposite to each other, displacement and force are opposite to each other, then the work done equals to 0, because work done is given by force into displacement into cos of theta, because work is a scalar type of quantity. Then we see for a dipole what will be the directions, or how you symbolically represent the electric fields and electric intensity. If there are the two unlike charges, then the fields are attract each other. Okay, but the two unlike charges are there, or both are the like charges, both are the positive, then the field lines are repel each other. If both are the negative, then at the negative they are closer, they are coming towards the negative in this way. And the final expression for the electric dipole, how we express the torque, and these are the different cases of the torque. Okay, and the next article is a capacitor. Before starting the capacitor, we solve the numericals on this part, and then we proceed for the capacitor and write down all the points in this video. in your own words. Read the textbook. Okay. See, these are the important cases which are mentioned here.